Okay, so we have just seen, how the hexadecimal number works. Okay, now we move on to users of the hexadecimal system. Where do we use this number system in the computer, and why do we use it? What are the benefits of it? Okay, that is what we are going to be dealing with in this part. Okay, so if you look over here, even though we know how binary works, now we know how binary works, we know how to convert it. Okay, they find, okay, so programmers, they find hexadecimal to be more convenient to use. Okay, so programmers and all that, they find using hexadecimal numbers. Do you remember when we started hexadecimal, I showed you the difference of how long a binary number is and how short a hexadecimal number is. I hope you remember that part. Okay, so it becomes very much more easier to read, convenient to use, easier to remember. Okay, things like that. Okay, now the same example has been repeated again. Okay, so they are saying if you take this binary number, this long binary number, if you take it, and if you were to convert it into hexadecimal format, it would simply be D2AF. Okay, that's it, D2AF. While in binary, it's such a long number. Now, when you have such a long number, reading it is difficult. Identifying a mistake in it is difficult. Okay, analyzing it is difficult. Okay, so that is why hexadecimal is preferred a lot more, because it is shorter, it has more digits. Okay, identifying mistakes in it becomes easier. Okay, that's why that language is preferred. Okay, now this section reviews 4 users. So over here, I have mentioned 4 different users of using the hexadecimal number system. Number 1, error codes. Okay, number 1 is error codes. There are so many error codes that are there in your computer. For each type of error in your computer, there is a code attached to it. There is a code connected to it. Okay, so when that error happens in your computer, that particular code is shown to you. Okay, now if the computer was to show you that code in binary, it's going to be a very long number, and it's going to be difficult for you to understand what the number is and what exactly is the error code. It's going to be very difficult. Okay, so the computer displays computer error codes using hexadecimal. Okay, then next there is something known as MAC address. Okay, so your computer's MAC address is also displayed using hexadecimal. Your computer's IP address, when you connect to the internet, when you connect to a network, your every computer is given an address, and that address is known as the IP address. So that IP address is also displayed, is also generated using hexadecimal. Okay, and then for color codes, okay, so you have about 16 million colors that can be displayed on a computer. Each color has a code. Okay, so 16 million is quite a long number. Okay, so instead of displaying it, if you were to display in binary, it will be even longer. Okay, if you were to display in decimal format, it will be quite long. Okay, so instead hexadecimal is used because hexadecimal will be shorter. Okay, so when it comes to displaying color codes in your computer, color codes on a web page, we use hexadecimal numbers to display the color code. Okay, instead of saying that this is the this is the 750,375th color, we simply put a short hexadecimal number. Okay, so over here I have given you all 4 reasons or 4 users of hexadecimal numbers. Okay, right. When we attempt past paper questions, you regularly get questions asking the users of hexadecimal, benefits of hexadecimal. So you will have to keep this part in mind. Okay, right. Then moving on to our next part. Okay, so in our next part, if you go on to page number 6, we talk about addition of binary numbers. Okay, how do we add 2 binary numbers? That is what we are going to talk about now. Okay, so if you were to take the number 7 in binary, this is how it is written. And if you take the number 14 in binary, this is how it is written. Okay, so now let me first show you how do we add 2 decimal numbers, and that same logic we will be using for binary numbers as well. Okay, so if you take the number 7 and you take the number 14, how do we add them? Okay, so we take 7 plus 4. 7 plus 4 is equal to 11. So we write 1 over here and we carry the other one over here. Okay, so this becomes 11. Okay, so what we do is we simply write 11 over here. Okay, something is definitely wrong over there. I made a big mistake over there. Okay, I made a big mistake over there. So if you take 7 plus 14, so 7 plus 4 is equal to 11. We put 11 over here and we put 1. It does not become 11, it becomes 2. Okay, we are adding 1 over here, so it becomes 1 plus 1 is 2. So we put 2 over here, it becomes 21. I'm so sorry for that mistake earlier. Okay, got confused with this. We were using it, what do you call, for the division, isn't it? Okay, so this becomes 21. Okay, so this is how we add in decimal number. This is how we add decimal numbers. Okay, 7 plus 4, we put the last digit we put, which is 1, and the first digit is carried forward. Okay, so this becomes 2, and we write 2 over here. Right, now what I want you guys to do is, I want you guys to observe how I add binary numbers. Okay, so we have two binary numbers over here. We have 0, 1, 1, 1. Important, when you add them, align them. Okay, otherwise, I mean, line them up properly, otherwise you can make a mistake. 1, 1, 0. Okay, right. So if we take 1 plus 0, okay, we're adding them. So 1 plus 0 is equal to 1. Okay, no big deal, no problem. 1 plus 1 is equal to 2. Okay, 1 plus 1 is equal to 2. Okay, here we have 1 and 1 is equal to 2. But we cannot write 2 because we're adding binary numbers, right? So what you need to remember is, how do we write 2 in binary? In binary, how do we write 2? Can you remember? So in binary, 2 is displayed as 1, 0. I hope you remember this. Okay, in binary, how do we display 2? This 2 is displayed as 1, 0. Okay, because if you have forgotten, let me remind you, the position value here is 1, the position value here is 2. Okay, so 1, 0 is equal to 2. Okay, then for example, if we were to display 3, in binary, if we were to display 3 is displayed as 1, 1. Okay, I hope you recall this stuff. Okay, you need this. Okay, so just keep that in mind. Okay, and if you take 4, for example, 4 is written as 1, 0, 0. Okay, right, I hope. Okay, so if you take 1 plus 1, it's 2. And in binary, how do we write 2? We write 2 as 1, 0. Okay, so we put the last digit and the next digit, we carry it forward. Okay, so this is 1 plus 1 plus 1, which is equal to 3. How do we write 3 in binary? We write it as 1, 1. Okay, how do we write 3 in binary? We write it as 1, 1. So we put the last digit over here and we carry forward the next digit. Okay, so now we have 1 plus 1, which is equal to 2. How do we write 2 in binary? We write it as 1, 0. So over here we put 1, 0. Okay, so when you add these two numbers, this is the result you get. Okay, this is your result. Okay, 1, 0, 1, 0, 1. Okay, so let me do one more example. Let's take another number. Let's take the number, for example, 1, 0, 0, 1, 1. And the next number we have is 1, 1, 0, 1. Okay, let's take a number like this, for example, and let's add them. Okay, so remember, 1 plus 1 is equal to 2. And you have to remember, 2 in binary is 1, 0. Okay, 2 written in binary is 1, 0. So you will write 0 and you will carry forward the 1. Okay, so now you have 1 plus 1. Okay, plus 0 is 0. I mean, 1 plus 1 plus 0. Okay, so again you have 2. How do we write 2 in binary? We write it as 1, 0. So we put 0 over here and we put 1 over here. Okay, so now we have 1 plus 1, which is again equal to 2, which is 1, 0. So we put 0 over here and we put 1 over here. Again, 1 plus 1 is equal to 2. 2 written in binary is 1, 0. So we put 0 over here and we put 1 over here. Now we have 1 plus 1, which is 1, 0. So we have to put 1, 0. Okay, so this is going to be your answer. If you want to check, is this answer actually correct? Convert it to decimal and see is it correct or not. Okay, so for example, this number, if I was to write it in decimal format, how much will it be? It would be 1 plus 2 is 3, 4, 8, 16. So 16 plus 3 is equal to 19. And this number, if I was to write in decimal, it would be 1, 2, 4, 8, 8 plus 4, 12, 12 plus 1 is 13. Okay, let's see what is here. So normally we should be getting, if we add these two, we should be getting 19, 29, 32. Normally we should be getting 32. Check and see, have we got 32 over here? Yes, we have 32 over here because we have 1, 2, 4, 8, 16, 32. Okay, this is 32. Okay, so it works. Okay, so you have to practice a few. I think I have given you all some questions over here. Sorry. In the tute, some questions have been given. Okay, on how to add. I mean, some questions on adding binary numbers. Okay, right. Right. Now we have something called an overflow error. So an overflow error is something like this. Okay. So normally your computer can represent 8 digits. Okay. If you have an 8-bit register, it can represent 8 bits. If you have a 16-bit register, it can represent 16 bits. If you have a 12-bit register, it can represent maximum 12 bits. If you have a 32-bit register, it can represent maximum 32 bits. Now, sometimes you can have a problem where you have an 8-bit register. Okay, and you added two 8-bit values. Okay, two 8-bit values you added, and what happens is, in the addition of these two, a 9th bit is generated. Okay, when you add these two 8-bit values, automatically what happens is an extra digit comes into play. So when this extra digit comes, there is no place to store it because your computer is only supporting 8 bits, for example. So there is no space to store this 9th bit. So then we tell our so then an error is created, and that error is what we call overflow error, where there is an extra digit and there is no space to store that extra digit. Okay, so I'll give you a very simple example. Okay, so if you look over here, guys, if you look over here, 0 plus 0 is 0, no problem. Okay, so we have a problem here. How did 1 come over here? We have a problem over here. Let's write this over here. Okay, so what is the value we have? We have 0, 1, 1, 0, 1, 2, 3, 0. Okay, and the next one we have is 0, 1, 1, 1, 1, 0, 1, 1. Okay, so if you would take a value like this, 0 plus 0 is equal to 0. Okay, 1 plus 1 is equal to 2. So we put 0 over here. 1 plus 1 is equal to 2. We put 0 over here and we put the 1 over here. 1 plus 1 plus 1 is equal to 3. How do we write 3 in the binary? We write it as 1, 1. Okay, so we put 1 over here and we put the other one over here. So again, 1 plus 1 plus 1 is 3. Okay, how do we write 3 in binary? We write it as 1, 1. So we put 1 over here and we put 1 over here. Okay, so now we have 1 plus 1, which is equal to 2. In binary, we write 2 as 1, 0. So we put 0 over here and we put 1 over here. So now we have 1 plus 1. Okay, so 1 plus 1 is 2. We write 2 as 1, 0. So we put 0 and we put 1. Now 1 plus 1 plus 1 is 3. We write 3 in binary as 1, 1. So we put 1 over here and we put 1 over here. Now 1 plus 1 is equal to 2. We write 2 in binary as 1, 0. Now remember, our computer is using only 8 bits. Okay, but now our answer has generated how many bits? 1, 2, 3, 4, 5, 6, 7, 8. It has generated, sorry, my bad. It has generated 9 bits. Okay, so there is no space to store this extra bit. So we say an overflow error has occurred. Okay, when this extra bit comes into play, we say an overflow error has taken place. Okay, so overflow error only happens when there is an extra bit that cannot be stored in the register. So you have to read the question. What is the size of the register? If the register is 16 bits, then this answer is all right. Okay, you have to read the question. Okay, but in this question, they have told only 8 bits. So there is no space to store the 9th bit. This is what we call overflow error. Okay, right. Next, we will be moving on to something called logical binary shifts. Okay, where we'll be making shifts in the binary number. We'll deal with that next. Okay, so next we have logical binary shifts. Okay,